In today's video, we will be looking at matrix operations, in particular, two operations, matrix addition and scalar multiplication. Please be sure to subscribe so you don't miss out on any future videos. Matrix addition is the operation of adding matrices by adding the corresponding entries together. To add two matrices, they must be the same size. Let's look at an example. Determine if matrix addition can be performed on the following matrices, A plus B and A plus C. In order to determine if matrix addition can be performed on these matrices, we must first determine the size of each matrix. And the size of each matrix is R times C. R is the number of rows and C is the number of columns. The size of matrix A is 2 times 3 because it consists of 2 rows and 3 columns. The size of matrix B is 2 times 3 as well because there's 2 rows and 3 columns. And the size of matrix C is 3 times 2 because we have 3 rows and 2 columns. Now, A plus B is defined because both matrices are the same size. However, A plus C is not defined because A and C are not the same size. Therefore, the matrix addition can only be performed on A plus B. Let's look at another example and add matrix A to matrix B. In order to add these two matrices together, we must first determine the size of each matrix. The size of matrix A is 2 by 3, and the size of matrix B is 2 by 3. Since the size of both of these matrices is equal, we know we can perform matrix addition. Since we are going to be adding the corresponding entries together, let's look at the first entry in matrix A and matrix B in row 1 and column 1. The value in row 1 and column 1 for matrix A is equal to 5, and in matrix B is equal to 2. Therefore, the value in row 1 and column 1 in matrix A plus B is going to be equal to 5 plus 2. Let's look at row 1 and column 2. The value in matrix A is equal to 5, and the value in matrix B is equal to 1. Therefore, the entry in matrix A plus B in row 1 and column 2 is 5 plus 1. Let's look at one more. In row 1 and column 3, for matrix A, we have a value of 0 and a value of 5 in matrix B. Therefore, the entry in matrix A plus B in row 1 and column 3 is equal to 0 plus 5. And we can use the same process for row 2 and column 1, 2, and 3. And finally, we get the matrix A plus B, where 5 plus 2 is equal to 7, 5 plus 1 is equal to 6, and 0 plus 5 is equal to 5. And the same can be done for row 2, column 1, 2, and 3. One thing to note is that the matrix after adding matrix A and B must be equal to the same size. And this matrix, A plus B, also has a size of 2 times 3. Scalar multiplication is the multiplication of a matrix by a scalar quantity. Let's look at an example. If matrix C is given, we must calculate 3C, which indicates that matrix C is multiplied by a scalar quantity with a value of equal to 3. In order to determine 3C, we must multiply each entry in the matrix by 3. So in order to determine the first entry in row 1 and column 1, we're going to multiply 3 times 2 to get a value of 6. And to get the second entry in row 1 and column 2, we're going to multiply 3 times 4 to get a value of 12. And the same process can be used in order to determine the remaining entries in matrix 3C. Let's look at another example. Given matrix A and matrix B, you would like to compute matrix 2A minus B. If we rewrite 2a minus b as 2a plus negative 1 times b, we can see that we are performing scalar multiplication twice by multiplying matrix A by a value of 2 and matrix B by a value of negative 1. And then we are using matrix addition to add these two matrices together. In order to do this, we must determine if these matrices are the same size, which they are. Therefore, we can proceed. First, we're going to determine the value of matrix 2A. And in order to do that, we need to multiply all the entries in matrix A by 2. Therefore, the first value is 2 times 1, which is equal to 2. 2 times 4, 2, which is equal to 4, and 2 times 3, which is equal to 6. And we can use a similar approach to determine the entries in row 2. Next, we move on to matrix B. And we're performing scalar multiplication on matrix B by multiplying it by negative 1. Negative 1 times 1 is negative 1, negative 1 times 7 is negative 7, and negative 1 times 3 is negative 3. And we use a similar approach to determine the values for row 2. Now that we have the two matrices, we must use matrix addition to determine 2a plus negative 1b. We need to add the corresponding entries in each matrix in each row and column. So in row 1 and column 2, for this matrix, we have a value of 2. And in this matrix, in row 1 and column 1, we have this value. So to determine the entry in row 1 and column 1 for matrix 2a plus negative 1 times b, we need to add 2 minus 1 to get this first value, and 4 minus 7 to get the second value, and 6 minus 3 to get the third value. And a similar approach can be used to determine the entries in row 2. Therefore, now we have a final answer of 2a minus b, where 2 minus 1 is equal to 1, 4 minus 7 is equal to negative 3, 6 minus 3 is equal to 3, 0 minus 1 is equal to negative 1, 6 minus 1 is equal to 5, and 10 minus 4 is equal to 6. Thank you for watching. Please like, share, and subscribe.